This conference will now be recorded.
All right, this is the continuation of the videos from the extra examples for 2.8, 3.1, and 3.2. I had to put this in a Word document because the PDF kept messing up, as you can see in the previous video. So I'm just put the section number and the number of the problem that it matches with in the notes so that you can reference that. So number 10 was an air traffic controller spots two airplanes at the same altitude converging to a point as they fly at right angles to each other. One airplane is 150 miles from the point and has a speed of 450 miles per hour. The other is 200 miles from the point and has a speed of 600 miles per hour. So before we even worry about what the question is, let's try to draw a picture of this. So the hard part about this one is how to draw it correctly. So what we want to do is imagine we're looking down on the two planes. So this is like airplane 1 and airplane 2. And they're flying at the same altitude, so they're the same height above the Earth, and they're going to be converging to a point P, so that means they're headed in the same direction towards that point. And I'm not a really good drawer, but it says that they're flying at right angles to each other, which means this is a right angle, so suspend belief. And it says one of the airplanes is 150 miles from the point. So we don't necessarily know that these two links are the same. In fact, they're not going to be. So this is 150, and it has a speed of 450 miles per hour. And this was miles right here. So think of this as being like an x side of this triangle, and then this would be dx dt. So speed, change in speed over the change in miles over change in time. The second side is going to be 200 miles, and its speed, which we'll call dy dt, is going to be 600 miles per hour. So then we have this distance that as the planes are traveling closer and closer to each other, we're going to call this distance, and this will be c essentially for our hypotenuse, even though my triangle looks bonkers. This c is unknown at the moment. We can find it using Pythagorean Theorem, but we're questioning how much is that changing. So at what rate is the distance between the planes changing? So that's what we're going to look for when we get to the point where we get ready to take our derivatives. So we need to find c by using Pythagorean Theorem. So that would be a squared plus b squared, since the 90-degree angle is always across from the hypotenuse, equals c squared. So we'll need our calculator. So that 200 squared is 40,000 plus 150 squared is 22,500. We had set that equal. And then we want to take a square root of that. So we're going to raise it to the 0.5 power because my square root button, I don't want to have to retype all that in. So we get 250. So C is 250 miles. Okay, so remember we're using kind of the formula here for Pythagorean theorem. So x squared plus y squared equals c squared. We're going to take an implicit derivative with respect to time because we're asking what is the rate and the distance between the plane changing. So feet per second, how is this, or miles per hour, sorry, how is this changing? So when we do that, that would be a derivative of that is 2x, tag on the dx dt, plus derivative of this is 2y, tag on the dy dt, and the derivative of this would be 2c dc dt. Okay, so let's plug in everything we know. 2 times 150 times 450 plus 2 times 200 times 600 equals 2 times 250 dc dt. And we're going to work that out. So this is 2 times 150 times 450 plus 2 times 200 times 600. So that means this side is 375,000 equals, that would be 500 dc dt. And if we divide this by 500, we're going to get a number, but we have to think about if it's the right value. So that's 750 miles per hour. The problem with this is you have to think when you give an answer like this, we solved it and it came out positive. That doesn't always mean that that's the right sign, especially if your distances are shrinking, or depends on if they're getting farther apart. So you have to consider, would this be the correct way for this? So as these sides are shrinking, is this distance going to shrink as well? Because as the planes get closer and closer to that point, it's going to be shrinking. So that's actually a negative 750 miles per hour. The distance is shrinking, and that's because it's decreasing as the planes get closer to P. Now, how much time does the air traffic controller have to get one of the planes on a different path? That's really just looking at kind of how does distance equals rate times time, and you can use either of the planes as a model for this. So if we use a 200 and 600 miles per hour, 200 is the distance, 600 is the speed or rate, and if we divide that, we get 1/3 of an hour, since that's what we're measuring time in, and that would equate to 20 minutes, because you times that by 60 to figure out how many minutes that is. So they only have 20 minutes to correct the course. Okay, so from section 3.1, I had a few that we skipped over in there. We want to find the open intervals in which each function is increasing or decreasing. Remember, we can tell that by looking at the slopes of the tangents. So we're going to be talking about the first derivative. So the first thing is we need to find some critical numbers. So we're going to times this by the 1/4. That would just be x to the third minus 16x. Factor out an x. That would make that x squared minus 16. And then factor the perfect squares into x plus 4 and x minus 4. Set each of those equal to 0. So we're considering 0, -4, and 4 as our critical numbers. We place those on a number line from least to greatest. So -4, 0, and then 4. We write our interval notation, so we'll have it for the end. And that just moves from left to right on the number line. We pick a test value in each region. As long as it's in the region, it's good. And then remember, you plug it into the derivative to see if it comes out positive or negative. That tells us if our tangent has a positive or negative slope. So if we plug in a -5, that would be negative times negative times negative. So that's going to come out as an overall negative. If we plug in -2, that I'm plugging it here into the factored form because that's quicker for me. That's going to be a negative, a positive, and a negative. So two negatives multiply to make a positive. If we plug in 2, that's going to be positive, positive, negative. So that's an overall negative when we multiply. And if you plug in 5, you get all three positives. So if you multiply, that's positive. So this means that we are decreasing on the interval -infinity to -4, unioned with 0 to 4, because those are our negative intervals. And we are increasing on the intervals -4 to 0, unioned with 4 to infinity. All right, let's look at the next one, number 4, from that 3.1. We need to take the first derivative again. So that's going to be 9x squared plus 24x plus 15. You can factor a 3 out of that group. So that makes that 3x squared plus 8x plus 5. Just makes it a little bit smaller to deal with the factoring. So that would be 3 times 5 is 15. Factors that make 8 is going to be 3 and 5 again. So factor by grouping would make this 3x squared plus 3x plus 5x plus 5. We're going to factor those by grouping. And that gives me a 3x and an x plus 1 plus a 5 and an x plus 1. So my factors are 3 times x plus 1 times 3x plus 5, which makes my critical numbers -1 and -5/3. Put those on the number line. -5/3 is actually smaller than -1. So my intervals are -infinity to -5/3, -5/3 to -1, -1 to infinity. That something smaller than -5/3 would be like -3. That would work. Between -5/3 and 1, you have to be careful because 5 divided by 3 is 1.666 forever. So you have to pick something between -1.66666 and -1. So maybe -1.2. And something bigger than -1, I'm going to go with 0. That's easy to plug in. And we want to plug those numbers into our first derivative here. And you just want to go with the factored form. It's just easier. So 3 is positive. -3 plus 1 is negative. -3 times 3 is -9 plus 5 is negative. So that's two negative factors, which makes it an overall positive. 3 is going to be positive, negative 1.2 plus 1 is negative. 3 times negative 1.2 is negative 3.6, and you add that to 5 and that actually comes out positive. So that's positive, negative, positive, which means the sign is an overall negative. If you plug in 0, you get all 3 positive things. So we are increasing on negative infinity to negative 5/3, unioned with negative 1 to infinity, and decreasing on negative 5/3 to negative 1. Now remember, the whole point of that is going to be in the next section. We're going to actually tell which one of those are maximums or minimums. So let's look at number 5. So fast food restaurants determine the cost and revenue models for its hamburgers. So this is the cost function. Here's the revenue function. If it was me, I would probably distribute that 1 over 20,000 to that. Let's just rewrite what that would look like. So 65,000 divided by 20,000 is 3.25x minus 1 divided by 20,000 is 4 zeros and then a 5. So 0.00005x squared, just to make it easier to do the derivative in a second. So it says write the profit function for this situation. So profit is always revenue minus cost. So that would be 3.25x minus 0.00005x squared. And then we have to subtract the cost function, which means we make both of those negative. So 0.6x and negative 75,000. So if we clean that up, that's going to be negative 0.00005x squared. 3.25 minus 0.6 is 2.65, and that would be positive x, and then minus 7,500. So there's my profit function. And then it says determine the open intervals on which the profit function is increasing or decreasing. So we need to take the derivative of the profit function, the marginal profit. So that would be 2 times that. So that's going to be negative 0.000. Let's make sure 0.0005 times 2. I know it's negative, so it's 0.001. And then x plus 2.65, and then the x goes away, and then no derivative. So if we want to figure out the profit function increasing or decreasing, we need to set this equal to the 0 and solve for x. So I would add over that x part, and that equals 2.65, divide by 0.001, 0.001, 000, sorry. So 2.65 divided by 0.001, sorry. That's 26,500. And then we're going to put that, remember, in the middle of our table. And that would give us the ratio. Now this was this had a defined domain, 0 to 50,000. So this is 0 to 26,500, and this is 26,500 up to 50,000, because that's all the hamburgers that they have. So we could pick something really easy here, like 1, because that's in that interval. We could pick something easy here, like 30,000, just something easy to plug in. So we're going to plug it into P prime of those numbers. If you plug in 1, that's going to be 2.65 minus 0.0001. So that's definitely going to be positive. If we plug in the 30,000, so that's 30,000 times 0.000, too many zeros, 1, that is negative, and then plus 2.65, that's going to end up being negative overall. So what we find is that this region is increasing and this region is decreasing. So you're going uphill to the point and then downhill. So that means that that actually is a max, and we're kind of defining that before we get to that section. So that tells us in C, how many hamburgers does the restaurant need to sell to make its maximum profit? It's the 26,500 for hamburgers. So that's part C. Here's part B, where we're increasing and decreasing. And then this was, part A was to find the actual profit function. So there's A, B, and C. And actually, to do B correctly, we would need to write the open intervals, increasing on, decreasing on. Okay, so the last section that we started into last time and we didn't finish it, I left a lot of these as polynomials, so I'm going to go through them with you real quick. It says find all the relative extrema for the following functions. So that means finding the maximums and minimums. We do that by doing the first derivative test, which means we take the derivative of the function, which is negative 6x plus 2. We set it equal to 0 to find the critical values. So add 6x over, divide by 6, that's going to be 1/3. You place that in the number line, and your intervals are negative infinity to 1/3 and 1/3 to infinity. You pick a test value in each reason, so I'll put 0 and maybe 1. We're going to do f prime of those numbers. If you plug in 0, you get positive 2, so that's a positive value. If you plug in 1, you get negative 6 plus 4, so that's a negative value. That tells me this is increasing and this is decreasing, which means this is a maximum. Now, that means that we have a relative maximum at 1/3 for x, and we need the y value. To get the y value, you plug 1/3 back into the original function because that's where ordered pairs come from. So negative 3 times 1/3 squared plus 2 times 1/3 minus 7. 1/3 squared is 1/9 plus 2 times 1/3 minus 7. Multiply the fractions, that'd be negative 1/3 when you reduce it, plus 2/3 minus 7. That's 1/3 minus, and we need to make 7 have a common denominator, so 21 over 3. So I'm getting negative 20 over 3. And again, you can use your calculator to help you with that. Excuse me. So let's do number 3. This is f prime of x would be 4x cubed minus 12x squared. We can pull out a x squared and a 4. So that would leave me with x minus 3. So if you set 4x squared equal to 0 and x minus 3 equal to 0, you get x equals 0, because that would be square root of 0, which with a plus or minus, which is still going to be 0. And then this would be x equals 3. So we're going to set those up on our number line from least to greatest. We cannot use 0 as a test value this time since it's one of our interval parts. So we have to pick negative 1, 1, and 4. We're going to put those each into the f prime. You'll want to put them into the factored form for ease of evaluating, or actually this one's not too bad for the original. But negative 1 squared is positive. Negative 1 minus 3 is negative. So a positive times a negative is negative. 1 squared is positive, times the 4 is still going to be positive. 1 minus 3 is negative, so that's going to be a negative. 4 squared is 16, times 4 is still going to be positive. 4 minus 3 is positive. Positive times positive is positive. Now this is the first time we've had one on our charts where we have two things back to back that are the same. That means that this value is not a max or min. It's going to be one of those like kind of points where you kind of go like this, where you just kind of flatline, but you keep increasing. But for us, it's actually decreasing, so it's more like that, okay? But this one, it goes decreasing to increasing. So that means that this point right here at 3 would be a minimum. So we have a relative minimum at 3, and then we need to plug that into the original function. So 3 to the 4th minus 4 times 3 cubed, that's 81 minus 4 times 27, which is 108. So it's going to be negative 27 when I work it out. So negative 3, negative 27, or positive 3, negative 27 is the relative minimum point. All right, just a couple more, and then we'll be done and caught up with where we want to hit next time, which is going to be with those absolute maxes and mins. So this is f prime of x equals 4x cubed minus 32. We can pull out a 4. That leaves me with x cubed minus 8. Now this tests whether or not you can factor, because that is a difference of two perfect cubes. So you need the cubed root of each would be x and 2, and you keep the same symbol. This is factoring a perfect cube. The second part of a perfect cube is a binomial, and it's always the first times itself, so that's x times x. The first times the second, we don't worry about the sign yet, and the second one times itself, which would be 4. The sign rule is same as the original, opposite to the original, always positive, so SOAP. Now when we set these equal, 4 does not give me anything when I set it equal to 0, but x minus 2 gives me 2. This guy does not factor, and if you try quadratic formula, so x equals negative b plus or minus square root b squared minus 4ac all over 2a. That's a way you can solve quadratics that don't factor. That's 4 minus 16 over 2. That is an imaginary set of numbers. So because this is a negative inside here, this is imaginary, which means it's nothing for us, okay? Because you cannot have imaginary numbers on the real number line. So the only one is 2. That's the only value we got for a possible max or min. So when we work on this, this is negative infinity to 2 and 2 to infinity. I would pick 0 and maybe 3 for my two test values. Going to plug them into f prime. It might be easier to plug it into this version before I completely factored it. So 0 cubed is 0, and that would be negative 8. So positive times a negative is a negative. And 3 cubed is 27 minus 8 is positive times 4 is still positive. So this is decreasing to increasing. So that is going to make that a minimum. So we have a relative min at 2 for x, and then we need to plug that into the original again to get the y value. So that is 16 minus 64 plus 4. That's really just going to be 16 minus 60. So that's negative 44. All right, and very last one that I'm going to do on the video for tonight. And then that'll, like I said, leave us one more to practice in class before we do absolute maxes and mins. We're going to do one that has the power rule. So this would be f prime of x equals 6x minus 4 squared. There is a chain here, but it's a 1, so it really doesn't make any difference. So the only value, since this is squared, it means it's the same factor twice. The only way we can equal 0 is if x equals 4. So this would be negative infinity to 4, 4 to infinity. Plug in 0 and maybe 5. So f prime of the number. If you plug in 0, you get negative 4 squared, which would be 16 times a 6 is a positive. Plug in 5, that's 1 squared, which is 1 times 6, which is positive. So this is continually increasing, which means this is not a relative max or min. So this one has none for the maxes or min. So sometimes on WebAssign, they're going to have you write does not exist for like both of those, because it'll have a blank for the max and a blank for the min. All right, so that's the end of this video, and I will see you guys in class next week.